Good morning. In this video, we are going to talk about multiplication of polynomials. This is a continuation of our video on polynomials. So for those who are asking about what is a polynomial, you can refer to our video on the addition and subtraction of polynomials. In the development of algebra, ancient Egyptians and Babylonian mathematicians used sentences to express their ideas about numbers. They used algebraic symbols. Then somebody thought of using algebraic symbols to represent those ideas concisely and efficiently. Then they developed algorithms and procedures for performing elementary mathematical operations on those symbols. When I say elementary operation, it means addition, subtraction, multiplication, and division. So we can situate this lesson on that part where we are learning procedures and algorithms in dealing with those algebraic symbols that represent real-world applications. Don't lose that idea that what we are doing here is we are learning the language of algebra in the same way that we need to learn English or any other language so that you can successfully communicate and learn the secret of that language. So let's begin the basic concept of multiplication. What do you mean by multiplication? You can think of multiplication as repeated addition. For example, if you multiply 3 times 4, it is just the same as adding 4 3 times. We call the 4 as the multiplicand, and we call the 3 as the multiplier. Now, notice that when you multiply 3 times 4, you will also get the same result as 4 times 3. The order of the factors does not affect the product. And we call that property of multiplication as the commutative property of multiplication. Later on, you will apply this property when we multiply polynomials. Visually, you can think of multiplication as counting objects arranged in a rectangle. You can think of the multiplicand and the multiplier as the side lengths of the rectangle, the length and the width, and the product is the area of that rectangle. So if you have 3 times 4, you can think of that this way. You have 4 objects, which is your multiplicand, and there are 3 groups of those 4 objects. And together, they form a rectangle with a length of 4 units and a width of 3 units. And the product 12 is the area. Please bear in mind that the product of 2 measurement is a new type of measurement. For example, if you multiply feet times feet, the result would be feet squared. So you can think of that this way. If you multiply a 1-dimensional object length and another one width, the result would be a 2-dimensional object, which is represented by the area of this rectangle. If you have a 2-dimensional object like this, and you multiply that with another dimension, let's say the height, the result would be a 3-dimensional object, which is this cube. That is what we mean by the product of 2 measurements is a new type of measurement. And for the notation that we are going to use, by convention, this is how we represent multiplication. We can write 2 variables side by side. It is implied that the operation is multiplication. So here, x is to be multiplied by y. You can also write numbers and variables side by side with each other, like 2x y means 2 times the variable x times the variable y. Do not think of this x as the multiplication symbol. We do not use x as multiplication symbol to avoid confusion. You can also write the same 2xy this way. We use parentheses. 2 times the quantity x times the quantity y. So this is also multiplication. We can also write it this way. 2 times parentheses x plus 3, meaning x plus 3 is one factor and 2 is another factor. You can also write it this way. 2x times the quantity x squared plus 2. This is also multiplication. When there are 2 numbers involved, you can write it as 2 times parentheses 3 times xy. That means multiplication. Please note that we avoid using x as the multiplication symbol to avoid confusion with the variable x. With that as our introduction, let's begin learning the skills now of multiplication of polynomials. Here is our scope and sequence. We'll talk first about monomial times a monomial, then monomial times a binomial, then monomial times a trinomial, then binomial times a binomial, and multinomial times a multinomial. The prerequisite skills here are your skills on the laws of exponents and operations on integers. If you need some review on integers, you can refer to our video on integers. So let's begin with multiplying a monomial times a monomial. Let's multiply x times x. Visually, you can think of x as a 1-dimensional measurement like this shape. We are multiplying x times x. So this is x times x. And the product of x times x would be this square with a side of x. This is x units and x units. And therefore, we now say that x times x is literally a square with a length of x units, and we write that as x squared. So x squared is literally a square with a side length of x. If you multiply x times y, the side length is x and the width is y units. And it can form a rectangle that looks like this. And the product is the area of that rectangle, represented by this orange rectangle. So x times y is a rectangle which we call as xy. For 2x plus y, you need two x's like this. So this is one x, another x, that's 2x. And y is this width. And the area would be represented by these orange rectangles. And we have two of that. So this is one xy, another xy. Therefore, the product of y times 2x or 2x times y is 1, 2. 2xy's. 2xy. I would like to note that you can also interchange the order. You can put the y here and the 2x on the other side without changing the product. The area is not affected by the order of the sides. Let's go to the number 4 problem. 2x plus 3y. So you need 2x and you need 3y's. So this is how we visually represent 2x times 3y. And for the area, we need to form a rectangle here. So let's do that. These manipulatives can easily be reproduced at home because I just cut out some old colored folders. So this is 1, 2, 3, 4, 5, 6. There are 6 xy's. So therefore, the product of 2x times 3y equals 6 xy. Notice that you can get that 6 by multiplying 2 times 3. 2 times 3 is 6. And then copy the x, copy the y. So that's what's happening when we are multiplying polynomials. You multiply the numerical coefficient and then you multiply the variables. 2 times 3 is 6. X times y is xy, as we have noted in number 2. So visually, 2x times 3y is 6xy. 6xy means 6 rectangles with a dimension of xy. Now let's move to the next one. How do you represent negative x times y? Using our manipulative, we always represent the negative with a red colored shape. So this is our negative x and this is our y. To multiply them, we put them like that also. Whenever there is an odd number of red color, we are going to use a red for the area because negative times positive is negative. There's one negative here and there's one positive. The result should be negative. So for our negative x times positive y, we are going to use a red colored area here, and that is this rectangle. The length is negative x, the width is positive y, the area is negative xy, represented by that red rectangle. The red color represents the negative. So whenever you are multiplying one negative and one positive, or one red together with another color that's not red, the area would be red. But if you have two reds, the area would be positive, so we'll not use red color for that. This is just application of integers. So this is negative x times y equals negative xy. So when you have negative x times negative y, so you have negative x represented by this red, and negative y is a little shorter than x in our symbolism, but it doesn't mean that y is always less than x. It's just a way for us to differentiate the two lengths. So we have negative x times negative y, the area would be positive xy. So negative times negative is positive, x times y is xy. So we have positive xy. So those are our representations of multiplication of monomial times monomial. So don't think of this xy as very abstract thing. They represent something, and one application of that would be in dealing with areas. But there are so many other applications of that. Now this time, let's move on to multiplication of monomial times a binomial. If we are going to multiply x times x plus 1, how do we represent that visually? So what you need is an x, and for the other part is x plus 1. So this is x plus 1. We need a rectangle with a width of x and a length of x plus 1. So let's form that rectangle. And that is now the product. So the product is this one, which is x squared, and this one, which is x. So we now write that x times x plus 1 is equal to x squared plus x. where this x squared is this square and this x is this x. Together, that is x squared plus 1. Notice that you can also get this answer by applying the distributive property of multiplication over addition. So what you have to do is distribute the monomial factor x to the first term inside the parenthesis. So x times x is x squared. Applying your law of exponent, you copy the x and you add the exponents. It's implied that there's an exponent 1 here. It's implied that there's an exponent 1 there. So 1 plus 1 is 2. And then you copy the common variable. X times 1 is this x. So you perform the distributive property of multiplication over addition. That happens when you have a monomial times a multinomial. Visually, that distributive property of multiplication over addition is like this. X times x is x squared. This is the result. So this is the x squared. And then x times 1 is this 2, and this is the area. So this is the first result, x squared. This is the second result, x. And the product is x squared plus x. Let's visualize 2x times the quantity x plus 3. So you need 2x here, and we need x plus 3 here. So this is 2x times x plus 3. The product would be this area. So let's complete that area. So we form a rectangle. And how do we read now this area? You have 2x squared. 2x squared. And you have 1, 2, 3, 4, 5, 6. 6 x's. So plus 6x. So the product of 2x plus 3 is equal to 2x squared plus 6. By applying the distributive property of multiplication over addition, if you multiply 2x times x, you get this 2x squared. That's the first one. If you multiply the 2x times the 3, 2x times the 3, 2 times 3 is 6, and copy the x. So you have 6x. Visually, this 2x squared is this one. The 6x is this area, represented by these 6 small rectangles. Next, let's do x times y plus 2. So you have the x here, and we need y plus 2. So this is y plus 2. 1 and 2. So this is y plus 2. The area would be a rectangle, which is also its product. So we have xy and 2 like this. So xy plus 2x is the product, which you can also get by the distributive property of multiplication over addition. X times y is this xy. X times 2 is 2x. The xy is this, that part. The 2x is this part. Letter D, 2x times y minus 3. So we need 2x here. And we need y minus 3. How do we represent y minus 3? We need to put these little squares on top of y, but flip that over to represent the minus 3. Think of that red part as that part that you cut away, so they do not exist anymore. So the y minus 3 is this purple part. Then we need to form that rectangle here. And to do that, we can start with xy and another xy, and then cut away that part that is represented by the red, because that should be removed. So we need 3 like this here. So that's how we represent 2x times the quantity y minus 3. So this is 2x, y is the purple, but cut 3 units represented by that red. So this visible orange area is the product 2x times the quantity y minus 3. But how do we read now our answer? Notice that I put 2 xy's under. So that means I have 2xy, but I cut away this red part, this red area, so that means I have to subtract 1, 2, 3, 4, 5, 6. So 6x. And this 2xy minus 6x is this area represented by the visible orange area. The red part are those parts that are already cut away and removed. But to represent the answer, we start with something that's whole. We have xy and xy, 2 xy's, and then we cut parts represented by 6x, and that's the area. So you can imagine now that when you become engineers, you'll be dealing with a lot of drawings and creating plans for your buildings. And those ideas that you might come up with would involve calculations of areas. And you can see now that abstractly, you can represent them with polynomials. And when you have polynomials, you have to perform operations on them. Next, negative 2x. Negative 2x, we need to flip this over to make that red. Times y, this are y, minus 1. So people put minus 1. Now, when you have one red and this visible non-red color, we have to use red for that. Now, you have red here and another red here. Red times red, negative times negative is positive. So we'll cover it with this positive, because negative times negative is already positive. Now, the area represented by negative 2x times y minus 1 would be this red, visible red area inside. And how do we read that one? Initially, we have two of those negative xy's, so we write them as negative 2xy. And then we have two of these x's, which are positive, so plus 2x. So the two xy's are the two red rectangles under, and the positive 2x are these two green small rectangles. The reason why we use green here is because when you have negative times this negative, the result is positive, which is represented by the non-red color. So that's how we represent monomial times binomial using algebra tiles and the equivalent abstract operation, which we call as the distributive property of multiplication over addition, which says when you have a monomial factor times a binomial factor or a multinomial factor, you have to distribute the monomial factor to each term of the multinomial to get your product. And your product is a binomial or trinomial if you cannot simplify them further.